Hello, I'm Rizan Salim. My IT number is IT21042324. This video recording is to demonstrate the progress of our secure software development module. So basically, to give a bit of an introduction, the system that we are working with is an online Ayurvedic store that was developed for our third year distributed system module. So when this project was developed, the main focus was on the functionalities rather than the security aspects, right? So even though we have an idea of what the security aspects that we have to deal with, we still use some tools such as dynamic code analysis tool and static code analysis tool to know the full extent of the vulnerabilities that we are dealing with. For the static code analysis, we used Sona Cloud, and for the dynamic code analysis, we used OWASP Zap. So my contribution to this project is to run this project to run a dynamic code analysis tool over this project and try to determine the bugs and try to fix them. So basically, this was due before the starting of the project. These were the vulnerabilities that were found. As we can see, the vulnerabilities has been divided as high, medium, and low. And like this is after the fixes have been deployed, right? So as you can see, the high vulnerabilities are gone, but still some of the medium and low seems to exist. Main reason these were not be solved was like clearly mentioned in the report, and I'm also willing to explain them during the Viva as well. But since we are working with limited time period for the demonstration of this project, I will just move on to the most common as issues that I worked with. So I'll just explain six common issues that I worked with here. So the first one is CSRF, right? So basically, to mitigate this issue, what we are trying to use is to create a CSRF token once the user logs in, and from there on, that token will be checked for subsequent requests. So basically, we are using a double submit cookie pattern, and to generate the CSRF token, I'm using a library called Crypto. And the next issue is about dealing with access control list. So for the access control list was like done in both front end and back end, right? So basically what we are doing is like when a user logs in, we are like giving him a JWT token. No, the token is there to authenticate the user, but there is something called user roles. So based on the user roles, we are routing the user, right? So we are giving protection to we are protecting certain routes based on the token and the user role. And in the front end also the same thing, based on the user role, we are like allowing permissions to certain pages. That means we are also in a way trying to solve direct object reference issue as well through this. So basically now I also created certain error pages. So in case like if someone tries to access certain pages that he doesn't have permission to. So basically if I try to access the seller page, I do not have access, so I will get this access denied page. After that, another issue is that the direct object reference issue that was again solved using through ACL. So the other issue is basically the improper JWT token management. So basically in the original implementation of the project, the JWT token has been sent through the response, and basically it has been stored in the local storage, and that token has been used for subsequent requests. So what we are doing here is basically attach the token as an HTTP only cookie so that it cannot be accessed by JavaScript, and it won't be like unnecessarily stored during local storage, so that it can be accessed by the users. And also we are using self-signed certificates here so that we can try to have this HTTPS communication, so that we can try to somewhat lower the chances of cross-site scripting attack and CSRF attack. These are some of the vulnerabilities that I worked with. Apart from the vulnerabilities, I also implemented a feature using Google OAuth. So basically the current system has only a custom login logic, but with Google OAuth, we are able to log in using a Gmail account. So basically once the user logs in, we are able to see his username and his profile picture on the top right. And the actual feature that was implemented is by accessing the Google People API, right? So basically when a customer sees a product, he is able to make a product referral to his other contacts. So when he click on this make referral, we fetch the contacts of his, and we are able to we give him the option to select the contacts that he wants to send the mail to. So basically like here I will select some of my contacts, and I will click on the send mail option. So basically, I'm able to select a product, make a referral to the contacts of my to the contacts under my Google email. So that's the idea of this feature. And with that, I have come to the end of my presentation. I'm further willing to explain during the Viva, and from now on, Johan will take over. Thank you.
Thank you, Riza. I'm Perela PYC and my student ID is IT211314424. So I will be demonstrating my contribution to this project, which is setting up the static analysis tool to identify the vulnerabilities of this system. So I use SonaCloud as the static analysis tool for this system. So the specialty of SonaCloud is that we can use GitHub Actions with it. So it makes sure that for every single push that we do to the repository, it will automatically analyze our project and give us a detailed report on the security, reliability and maintainability issues that we have. Also, I used Sona's CNES report plugin in order to get a much more detailed report of this system, so we can identify and analyze this much further. So by analyzing these reports, we came to a conclusion that there's an issue in regards to user control data where this system was at a risk of NoSQL injection attacks. So to address these issues, we use various different methods. So these are some of the methods where we first sanitize this input data, and then we also use this valid method here to make sure that these object IDs are valid object IDs. Also, we used here find by ID instead of find one in order to make sure that this uses the MongoDB's ID field, because the ID field of MongoDB is not susceptible to NoSQL injections. Also have used here the save function, which makes sure that this matches the schema of the MongoDB. So there are many NoSQL injection vulnerability functions here. So these have been addressed by similar methods as well as different methods. So I'll be willing to explain them in the upcoming Viva. So that will be my part of the demonstration. Over to you, Arun.
Thank you, Johan. My name is Arani Vijayaratna and my IT number is IT21014536. So in this project, I focused on enhancing the security of various forms, including the for payment, store, product management, login, and registration, as these protections were not in place in the original project. First, I implement input validation on the front end using HTML5 attributes and regex patterns. I ensured fields like email and password were validated before submission. I also used DOM Purify to sanitize any potential malicious inputs in the front end, preventing XSS attacks by removing unsafe characters. Additionally, I introduced custom encoding techniques to handle special characters securely. I added backend validation and sanitization using the validator library. I ensured that all user inputs such as the IDs, email, addresses, and form data were validated and sanitized by escaping potential harmful characters, adding an additional layer of security to prevent injection attacks and XSS attacks. For password security, which was not enforced in the initial project, I introduced strong password policies. These policies requires a minimum length and the inclusion of uppercase letters, numbers, special characters to prevent weak password usage. By implementing these security measures, I significantly strengthened the system's defenses against common vulnerabilities. Um, Thank you, and over to you, Kausha.
Thank you, Arani. My name is Vijayasundar WMKH, and my IT number is IT21149412. And this is my contribution to the project, which focuses on black box testing, backend logging, and improving the resource configuration for our containers. To ensure the security of our application, I performed black box testing using OWASP Zap, a powerful tool for identifying vulnerabilities in web applications. Through automated scans and manual testing, I was able to detect potential threats such as insecure cookies, cross-site scripting, and missing security headers. This testing provided valuable insights into how attackers might exploit vulnerabilities in our app, allowing us to patch these issues before moving forward. After the security testing, I enhanced the backend by integrating a structured logging system using the Winston login library. This allows us to track important activities across the application, such as API requests, error handling, and system events. The logs will be added to a separate log file like this. By adding these logs, we not only improve our ability to debug issues, but also it will provide a clearer audit trail that can help with security monitoring and diagnosing performance bottlenecks. Lastly, I addressed an important configuration issue flagged during our static code analysis. Our Kubernetes containers configuration were missing proper memory and storage limits, which could lead to performance issues and even system crashes due to resource overconsumption. I fixed this by specifying memory and informal storage limits in the Kubernetes YAML configuration. This ensures that each container operates within its allocated resources, improving stability and preventing potential downtime. With that, we have come to the end of the demonstration. Thank you.